Hi guys, welcome to the channel. I'm the Jacobian dev, and in this video I'll be going through how to export selected categories from Revit to Power BI using an SQL database. I've gone ahead and opened one of the Revit sample projects. In the Jacobian dev tab, I'll launch the SQL export plugin. Here we can see all the Revit categories. I'll search for doors. I'll then search for ceilings, then the floors, and lastly the walls and windows. I'll then export all the category parameters. Back in the SQL Management Studio, I'll refresh the Jacobian database. Here we can see all the exported categories. I'll select the first 1000 rows for the windows, and here we can see all the exported windows with their respective parameters. The next step would be to visualize the data by creating a dashboard. I'll open Power BI. I'll select Import Data from SQL Source. I'll add the SQL server and database. And here we can see all the categories. I'll select all the exported categories and load them in. In the Data tab, we can see all the exported Revit categories and their respective parameters. Once the data is imported from SQL, you can then proceed to create your dashboards, which would allow for easy identification of trends, areas of concern, and opportunities for improvement in the Revit model. To get started, I'll head to Visual Studio where I have a SQL Power BI project set up. If you're not sure how to set this up, I've added a link in the description for the first video in the channel on how to create a plugin in Revit. I'll start by adding a label. I'll then change the label's text properties to search. I'll then add a text box. In the text box properties, I'll change the text box name to txt search. Back in the UI form, I'll copy the search label. I'll then change the copied label's text to categories. Next, I'll add a data grid. I'll adjust the grips and layout. In the data grid's properties, I'll change the background color to control. I'll change the name to DG categories. And back in the form, I'll add a button. I'll change the button's name to BTN export and the button's text to export data. I'll double click on the button to access the button's click event function. Before we add the code to export the data, back in the form, I'll double click on the form to access the form's load function. Here I'll start by connecting to the SQL server. Next, there are a few variables that need to be declared. I'll start by declaring a static read-only array named valueList, which calls the enum getValues function, passing the built-in category type of as a parameter. Next, I'll declare a new list of type built-in category named built-in cat array, which will filter the value list by built-in category type and return a list. Next, I'll declare a new static read-only hash set named checked rows, which will be a new hash set. I'll then declare a new data table named DG categories without the underscore. Next, I'll declare a new bind data function to add data to the data grid as the form loads. There are a few categories I want to remove from the built-in cat array. I'll remove all the categories that contain deprecated. I'll then remove categories that contain obsolete. I'll then remove all the categories that contain hidden lines. And lastly, I'll remove any category that is invalid. Next, I'll check if there are any columns added to the DG categories data grid. If there aren't any columns, I'll create and add a new data column named categories of type string. I'll then iterate through all the built-in categories in the built-in category array. Next, I'll declare a new category variable, which will be the category with the OST prefix removed. I'll then add the category to the DataGrid's rows. Next, I'll bind the DataGrid's data source to the DG categories data table. I'll then declare a new DataGrid view checkbox column named checkbox column. I'll set the checkbox header text to an empty string. I'll then set the column width to 30 and the column name to checkbox column. Next, I'll insert the checkbox column to the DataGrid at the first position. I'll change the first column's auto size mode to all cells and the second column's auto size mode to fill the width of the DataGrid as it resizes. And lastly, I'll sort the categories column in ascending order. Back in the UI form, I'll select the DataGrid, and under the events, I'll select on the cell end edit event function. In the function, I'll start by iterating through all the DataGrid view rows. I'll then declare a new bool variable named isChecked, which will get the boolean value of the checkbox column cell. Next, I'll check if the row is checked. If true, I'll declare a new string variable named selectedCat, which gets the selected cell value. I'll then add the selectedCat variable to the checked rows hash set. Back in the UI form, I'll select the text box, and under its properties, I'll activate the text change event function. In the function, I'll start by declaring a new data view named DV, which gets the default view of the DG categories DataGrid. Next, I'll add a row filter to the data view, which will search for categories like the text provided in the text box. I'll then set the DataGrid data source to the data view. This will help search for specific categories. I'll then iterate through all the DataGrid views rows. I'll then copy the selectedCat variable, which gets the selected cell value. Next, I'll iterate through all the checked rows. And if the checked row's value is equal to the selectedCat variable, I'll set the cell value of the checkbox column to true. Next, we need to get all the parameters from the selected categories. There's an article on how to get the element parameter values by the build encoder. I've added a link to the article in the description. The article goes through using the filter category rule versus the category filters. Before getting the element parameters, I'll call the bindData function in the forms load method. Back in the article, I'll copy the mapCat2UID variable, and back in Visual Studio, I'll add it to the export function. The variable is a dictionary with the key being the category and the values being a nested dictionary, with the key being the element's unique ID and the value being a list of the parameter values. Next, I'll set the search text box value to an empty string. I'll then declare a new string variable named project name, which gets the document's title. Next, I'll iterate through all the DataGrid views rows. I'll declare a new string variable named selectedCat, which gets the selected cell value. I'll then iterate through all the checked rows. And if the checked row's value is equal to the selectedCat variable, I'll iterate through all the built-in categories in the built-in category array. Next, I'll declare a new variable named cat, which is the built-in category string value, with the OST prefix removed. I'll then check if the selected category is equal to the built-in category. If true, I'll declare a new string variable named category, which will be the project name and built-in category separated by an underscore. I'll then remove all empty spaces from the newly declared category variable. Next, I'll add the system text regular expressions reference. Back in the export function, I'll use a regex to replace all the numbers from 0 to 9 with an empty string. I'll then check if the category contains a dash. If true, I'll replace it with an underscore. I'll then add the category in an empty list to the mapCat2UID variable. Next, I'll declare a new list of type element ID named BICID. I'll then add a new element ID to the list from the built-in category. Next, I'll declare a new iList of type element filter named A. I'll then add a new element category filter passing BIC as a parameter. Lastly, I'll declare a new variable named category filter, which calls the new logical OR filter, passing the element filter A as a parameter. The next step would be to run the collector. Back in the building coder article, I'll copy the ELS collector, and back in Visual Studio, I'll add it just after the category filter. I'll then declare a new list of type string named paramListParams to get all the paramList parameters. Next, we need to check if a SQL table exists. For that, I'll paste the table exists function from the export Revit data to SQL database video, which I've linked in the description. Then back in the export function, I'll declare a new bool variable named doesExist, which calls the table exists function and requires the database name Jacobian and the table name category as parameters. If the table exists, I'll declare a new SQL command variable named command, which calls the SQL connection query function, passing the query drop table plus the category as parameters. This will drop the table if it already exists. I'll then execute the SQL command query. Next, I'll iterate through all the elements in the ELS filtered element collector. Next, we need to get the element parameter values. So back in the building coder article, I'll copy the getParamValues function. And back in Visual Studio, I'll add it above the table exists function. Next, I'll add a string value to the paramValues list, which will be the parameter definition name, equal to the parameter as a value string. Back in the export function, I'll declare a new list of type string named param values, which calls the getParamValues function, passing the element as a parameter. I'll declare a new family name variable, which will be the string family name, equal to the element's name. I'll then add the family name variable to the param_values list. I'll also declare a new element ID variable, which will be the string element ID, equal to the element's ID integer value. Next, I'll declare a new string variable named UID, which will get the element's unique ID. I'll then add the UID and the param_values list to the mapcat_to_UID dictionary at the category key. Next, we need to get a distinct list of all the parameters to use when creating the SQL table and saving the data to SQL. I'll iterate through the param_values list. I'll then split the parameters and the parameter values, separated by an equal sign, into a list named eleparams of type string. Next, I'll declare a new string variable named eleparam, which gets the parameter from the eleparams list with all the white spaces removed. I'll then check if the eleparam string contains a dash. If true, I'll replace it with an underscore. Lastly, I'll add the eleparam string to the param_list params list. Next, I'll declare a new list of type string named distinct params, which gets all the distinct or unique values from the param_list params list. I'll then declare a new string builder named SQL create table. I'll add the string create table plus the category and the unique ID, which is a variable character and cannot be null. I'll then declare another string builder named SQL save data. I'll add the string insert into plus the category and the unique ID. Lastly, I'll declare a new string builder named SQL save data values. I'll then add values and the first parameter to the string. Next, I'll iterate through the distinct params list. I'll check if it's the last index. If so, I'll add a comma, the distinct parameter value, which will be a variable text character, and a close bracket to the SQL create table string builder. I'll also add a comma and the distinct parameter value and a close bracket to the SQL save data string builder. And lastly, I'll add the string param with the index +2, since the unique ID is the first parameter. If it's not the last index, I'll append the same string values, just without the closed bracket. Next, I'll declare a new string variable named tableQuery, which will be the SQL create table string value. I'll declare another string variable named setQuery, which will be the concatenated string value of the SQL save data and the SQL save data values string builders. Next, I'll iterate through the map cat to UID dictionary. If the dictionary value count is greater than 0, I'll iterate through the dictionary's inner pair, which contains the unique ID and the parameter list. I'll declare a new string variable named unique ID, which will be the dictionary's inner key. I'll also declare a new list variable named paramList, which will be the inner pair value. I'll check if the SQL table is created by calling the TableExist function, passing Jacobian and the category as parameters. If the table exists, I'll declare a new try-catch statement. Next, we need to save the parameter data to SQL. Therefore, I'll create a function named saveParamsSQL, which requires the paramList as the first parameter, the setQuery as the second, the unique ID as the third, and a list of the distinct parameter values as the last parameter. I'll declare a new SQL command named command from the SQL connection query and pass the setQuery as a parameter. Using the command parameters add with value method, I'll add the element unique ID as the first parameter. Next, I'll declare a new list of type string named paramListParams. I'll iterate through the param list. I'll then split the parameters and the parameter values separated by an equal sign into a list named eleparams of type string. Next, I'll declare a new string variable named eleparam, which gets the parameter from the eleparams list with all the white spaces removed. I'll then check if the eleparam string contains a dash. If so, I'll replace it with an empty string. Lastly, I'll add the eleparam string to the paramListParams list. Next, we need to remove any duplicates in the parameter lists, if any. I'll iterate through the param list twice to compare the values. I'll copy the element params list and the element param string. I'll then add a suffix j to the variables and change I to j. If the element param is equal to the element param j value, I'll remove the item at index j for both the param list and the param list params. Next, I'll iterate through the distinct parameters list. I'll get the index of the paramListParams parameter that is equal to the distinct parameter. If the index is greater or equal than 0, I'll declare a new try-catch statement, catching any SQL exceptions and displaying them in a message box as a string. I'll copy the eleparams variable and paste it in the try-catch statement. I'll change I to index and 0 to 1 to get the parameter values. I'll then rename eleparam to eleparam value. I'll declare a switch statement using the eleparam value to remove a few unwanted characters. For the first case, I'll remove and replace the degrees character with an empty string. I'll copy the above case a few times I'll then remove meters cubed as the second case, none as the third case, and meters squared as the fourth case. Using the command parameters add with value method, I'll add the eleparam value. If the index is not greater or equal to 0, using the command parameters add with value method, I'll add an empty string, which I'll also wrap in a try-catch statement, displaying the SQL error message in the catch statement. Lastly, I'll call the command execute non-query function, which will save the parameter values to SQL. Back in the export data function, I'll call the save SQL params function, passing the param list, the set query, the unique ID, and distinct params as parameters. I'll then catch any exceptions and display them in a message box. If the table doesn't exist, I'll copy and paste the try-catch statement above. I'll then declare a new SQL command, passing the table query as a parameter. I'll then execute the SQL command to create the table. If there isn't any element category data found, I'll print to the console, no data found. I'll then clear the mapcat to UID dictionary. Lastly, I'll display a message stating the data was successfully exported. I'll then clear the checked rows hash set. I'll also set the dialog results to OK. And lastly, I'll close the form. I'll save the changes and start the project. I'll select Always Load to load the plugin. I'll open a sample project, and in the Jacobian Dev tab, I'll select the SQL Export plugin to display the form. I'll search for ceilings, then doors. I'll then select the walls and windows categories. I'll click Export to export the data. Back in the SQL Management Studio, I'll refresh the Jacobian database, and under the tables we can see the exported category data. I'll select some of the rows in the walls table, and here we can see the data was successfully exported. That should be it for this video. If you have any questions or suggestions, please leave them in the comments below. I've also added a link in the description to the Jacobian Dev site, where you can download the installer under Revit plugins by just creating a free account. Please do remember to like, share, and subscribe.